Hello and welcome to the June edition of Jack's Doug. Thanks for joining. If you have any questions, hit the comments window there. We get to them as soon as we have a minute. And we are looking for speakers and also for topics. So if you have any particular topic you're looking for, please reach out to us on Meetup or in chat here. Let us know what you're looking for so we can try to find a speaker to meet that need. Want to introduce Jason for tonight's session, and he's going to be discussing Kubernetes. So I will turn it over to Jason now. Jason, take it away.
All right, thanks, Jeff. We're going to be talking tonight about improving deployments with Kubernetes. So first, just a little bit about who I am. My name is Jason Gerard. I'm a native of Jacksonville. I've been writing software for a long time, 20 plus years. I've worked in healthcare, insurance, finance, telecom, worked for cloud providers. You can follow me on GitHub, Medium. I probably haven't written anything there in a while. And Twitter, if you want to get in touch with me, Twitter DM is probably the quickest way to do it. All right, so tonight we're going to have an overview of containerization in Kubernetes, and we'll go into some details on what it means, what containerization is, what it means to containerize your applications, how you can orchestrate those containers and what that means. Specifically, we'll talk about Kubernetes. I'll go into some demos on using Kubernetes and different ways that you can take advantage of Kubernetes to deploy your application, even if you just want to deploy to a test environment and keep your traditional systems in place for your production deployments. And then we'll be open to questions. So the first thing I want to kind of go over is how applications are deployed. I think everyone here is probably a software developer, and you've written code, you've compiled it, and you've run it locally. That's the traditional model where you have apps, they're running on a operating system that's running right on top of hardware. That's what's happening for your local deployment, and depending on how you're deploying it, that may be how it's running in production too. But probably most of us are actually deploying into a virtualized environment where whether it's Azure, AWS, Google, IBM, or it's our on-premise data center where we're running VMware or Hyper-V or OpenStack or something like that. We have a bunch of hardware that's running some operating system, which is then running, or a hypervisor, which is then running actual virtual machines on top, Windows Server, Linux, what be it, and that's actually what's running our application. So one physical machine may be running, 10, 20 virtual machines that have our database and have our application server and whatever else we need. I think that's the model that most of us have been familiar with for quite a while now. And then the model that's emerged in the last 6 years now, I'd say, would be it's an evolution of that, where we're deploying our applications using containers. And it's not really much different than the other models. It's just a different way of packaging and deploying those applications. So just kind of keep that in mind as we go. So the first thing let's talk about is let's get to a common definition of what containerization is. A container is not a virtual machine. With a virtual machine, you have a hypervisor of some kind that's going to virtualize the hardware of the machine and expose it to another bit of software, typically an operating system, to run. So that operating system doesn't really know that it's running on virtual hardware versus real hardware. And that provides lots of isolation. And you've got the stuff like the DTX extensions and everything that's been done in hardware to really help that out. So you have really good isolation between your application that's running in a VM and another application that's running in a separate VM on the same physical machine. What a container is, though, is it's an OS level virtualization. So we're not virtualizing the operating or the virtual machine. We're not virtualizing the hardware. We're virtualizing the operating system. So we're going to provide process and resource isolation to the application, but we're still going to have the shared operating system kernel between all of those processes. So an example would be I run two applications. I run a web browser and I run a word processor. They're both running on my machine. They're both using the operating system kernel. Same with a container. If I have two containers running, they're both sharing that kernel. Whereas if I had two VMs running, they have their own kernel running inside that VM. So let's look at the history of containers a little bit. Some of these concepts are actually older than I probably bet some of the people in this talk here. It started with the change root command, which came out in Unix version 7 in 1979. And this command was very simple. It allows you to say a application when it's running, what its root directory looks like. So if you were to say run an application from your home directory, so in Windows it'd be like c:/user/JSON. And if that application were to run, it would say, hey, what directory am I in? It would see that it's in c:/users/JSON. And if it wanted to go up to the root and then change into the Windows directory and see what's there, it could. With the change root, though, you would say, I'm going to have this application in my home directory, but I'm going to make the home directory the root. So now when I do that and I run this command and it says, hey, what folder am I in? Physically on my machine, it's in my home folder, c:/users/JSON. But the application thinks it's at c:, essentially. It thinks it's at the root. And then when it says, hey, what are the files around here? It can only see what's in my home directory and below. And so it thinks that it's at the root. So this is the key, one of the key pieces of technology that was started there. And it's not a security, it doesn't provide security out of the box in that way. There are ways to break out of that. But all the other things that we layer on top of that make a pretty powerful and secure system. So the next technology that came out was jails and FreeBSD in the year 2000. That kind of built on that change root and some other stuff. And then we had Solaris, which was another Unix variant, had zones and then containers that came out in around 2004 that provided more functionality, more isolation. In 2006, Google created the C groups, which is short for control groups, and contributed to Linux to help with some of the isolation they were doing. And then in 2008, a project called LXC, which stands for Linux Containers, was created to kind of emulate some of the work that had been done for Solaris containers and bring it to Linux. And then in 2013 is when Docker was released. And Docker initially was built using LXC technology and adding on top of it. And Docker is what really brought containers to the mainstream because it made it easy to use. And then in 2015, we had the Open Container Initiative where Docker donated some of its format and some of its technology and made it all open source. And that's what everything's being built on today. So from now on, when I say container, I'm specifically talking about an OCI format container. It's going to provide namespace isolation, both process, network, and file system. So the file system would be like just what I talked about with that change root command. Like I can only see what's been exposed to me, and I can only see things that I can only know about things that have been exposed to me. So I'm going to be rooted somewhere, and I can't get out of that. Process isolation. So if you were to open up Task Manager on your system, you can see all the processes that are running. inside of a container, you can only see the processes that are running inside that container. And one of the things, since this has been primarily a Linux-based technology here with these OCI containers on Linux and Unix, when the operating system starts, you have a initial process ID called PID1, and then everything goes up from there. So every time you have a container that starts, it's going to get a new namespace, and it's going to start from there. So from the outside, the processes are 6500, 6501. On the inside, they're process ID 1, process ID 2, and they don't know about any of the other processes that are running. They do share the OS kernel, so all of those containers will be using the shared Linux kernel. There is native support for kernels or for containers on Linux and Windows. This was initially Docker was developed for Linux. It runs natively on Linux. And for the longest time, when you ran Docker on Mac or Windows, you were not actually running Docker on Mac or Windows. You were running a Linux VM in the background, and the Docker command was talking to that VM and running things inside that VM. That's still the way it works on Mac. On Windows, if you run a Windows container, that is running in Windows. If you run a Linux container, that's going to run in a virtual machine. And then Windows also has the concept of VM isolation using Hyper-V, which will actually spin your container up inside a separate, super lightweight Windows virtual machine to run your Windows containers there. That's about all I'm going to talk about that, because I've never really used it on Windows that much, but it's a deep dive to research. Container orchestration. Container orchestration is the ability to take all these containers we built that have container applications and then run them on one or more machines. And so it's no different really than you have, let's say you have a bunch of microservices or something, and you need them to run across a cluster of machines. You may be deploying them to IIS or running them under Nginx or something, or deploying them using like Elastic Beanstalk or something like that. So this allows you to use the common building block of a container and then run that anywhere. So some of the early examples of this would be Google Borg. That was a project that they created that's actually they're still using. That's how they run all their infrastructure. And Kubernetes actually came out of that. I'll talk about that in a minute. There was Apache Mesos, which I think was announced in like 2009. There was some research out of UC Berkeley that people were starting with this. And then around 2014, 2015, they kind of switched to hosting Docker containers. And then I think by like 2016, it kind of like was kind of on the back burner because everyone had switched to Docker Swarm or Kubernetes. Docker Swarm was another thing that came out for a while there. They eventually dropped that and embraced Kubernetes. HashiCorp Nomad is another technology that you can use. It's not entirely open source. I've never used it, but HashiCorp's got a lot of good stuff. It has a smaller scope than Kubernetes. It's really just for orchestrating and running the distributed containers. And then Kubernetes, which will be the focus of this talk, is the engine. So a little bit of history in Kubernetes. First of all, it's a Greek word, and I know I'm not pronouncing it right. It's probably like Kubernetes or something. I'm not quite sure how to pronounce it, but it means helmsman in Greek, and because essentially it's driving the ship of your application. So the project started at Google in 2014. It was started by I think three gentlemen, and then more people started joining on, and a lot of people that had formerly worked on the Borg platform at Google. It had a 1.0 release in July 2015, which was, I want to say I started working with Kubernetes around the 1.3, 1.4 release, so it wasn't too long after that. It was designed as an open source reimagining of Google Borg. So all the concepts and lessons learned that they had learned working on Borg, they re-implemented. Borg is written all in C++, while Kubernetes is written entirely in Go, and lots of YAML, as we'll see. It was originally called Project 7, after 7 of 9 from Star Trek Voyager. So Jerry Ryan's character on Star Trek Voyager, which was a former Borg. And then the logo here has 7 points in the wheel there, which is a reference back to that Project 7. I learned that like today. So Kubernetes is a distributed scheduler. So what that means is we have one or more machines running, and it will determine what runs where and on what machine, and for how long. It provides service discovery. So you can say, I need to talk to service X. It will say, here is service X, go talk to it. And it primarily does that through DNS. It provides configuration management, so you can store all of your application configuration in Kubernetes and then expose it to your applications and then update it through Kubernetes. And it uses a desired state configuration. So you define how you want everything to be, and it makes it that way. So you say, I want 5 copies of this application running at all times, and it will make sure that there's 5 copies running. And if one of them crashes, it will automatically restart it. You can configure it to automatically scale out, up and down. So you can say, I want 5 copies running, but if I hit this certain threshold of CPU or memory usage, I want you to scale out to up to 10 copies, and it will do things like that for you. Okay, so the structure of a Kubernetes cluster is you have a control plane, which is kind of the master. It has the API, the scheduler, and the controllers there. And then you have your nodes. They run what's called the kubelet, which is kind of the workhorse that handles, keeping everything running on the machine, and the proxy for your networking. Typically, if you're using Kubernetes in a cloud environment, your cloud provider is going to control the master, and you will never, that part of that control plane, and you'll never have to deal with that. So if you're using Amazon's EKS or Azure Kubernetes Service or Google Kubernetes Engine, they all abstract away the control plane for you. So you only see, have to deal with the nodes. So I like to think of Kubernetes as a cloud native operating system. And so let's take a look at how an existing operating system works. If you think about it, your computer running Windows or Linux or Mac, you have your shared resources, your RAM, your disk, your network. You have one or more CPU cores, which are going to do the processing. The operating system has a scheduler that's going to say, run this thread at this, on this core for this long, and it's going to handle all the context switching. And then you have your processes, which are made up of one or more threads, which are your applications that are actually doing work. This is very similar to Kubernetes. So the building block in Kubernetes is a pod, and a pod contains one or more containers. You can think of those as your threads. It has a scheduler. You can think of your nodes as your compute, and then they all share. These containers are going to be sharing the RAM and the disk and the network of the cluster. So if you think about containers as processes or threads, and pods as processes, it can kind of help you get your mind wrapped around some things. So the building blocks of Kubernetes. We talked about what a container is. So the first building block is a pod, which I'll go into here in a second. And then we have deployments, jobs, and daemon sets. Those are different ways to allow for certain ways to run your pods. Services are for the service discovery, so exposing your pods to other pods, and then ingresses are for exposing your services to the outside world. There's much more in-depth items like volumes and persistent volume planes and whatnot. Not going to go into detail on that because we'd be here all night. But there's much more to Kubernetes than just this. But these are the basic building blocks that you can build your application from. So a pod in Kubernetes is kind of the smallest unit of work you can do. It's going to consist of one or more containers, and it defines the environment, the storage, the image, all the constraints for that container. So in this example here, I have a pod. It has a name, my app, and then like a little hash there. It consists of one container that's using this theta D my app image. Image pull policy says every time you start up, refresh and grab the latest version of this image. We named the container also my app. And then we're going to expose port 3000 from this container, and that we're going to always restart it. So if this container crashes, go ahead and restart it. You know, options, you also say never, so it can run. Once it dies, it's not going to restart it. Deployments. So everything uses this pod spec that we just saw here. And so a deployment specifies one of those pod specs and a number of replicas. So this is where you would use, if you have a web app and you need 5 instances running, you would create a deployment of it and say, run 5 replicas for me. If you need something to just start up, run, and terminate, you would use a job. So if you had a pod spec and let's say you have like something that you need to run monthly to, generate some data for a report in the database, you could create a job that's going to run. It's going to crunch those numbers, and then it's going to terminate once it's done. And then Kubernetes actually has cron built in also, so you can actually schedule that like you would a cron job to go at specific times. And then a daemon set specifies a pod spec that should have one instance on each of your nodes in the cluster. So if you need to run a service on all of the nodes, the way to guarantee that there's one instance on each node is to use a daemon set. And that's for things like log collectors and really anything that you would run as a service where you want every single node in your cluster or within your list of nodes that you want it to run on to have one copy of it. With a deployment, you don't really control how many copies are running on the same node and where they're running. There's some ways you can influence where it runs, but and then it will try to run, to spread it out amongst all your nodes. But you could have a node that's got 2 copies running, and then you can have another node that's 1 and another node with none. Whereas a daemon set's going to run 1 copy everywhere. A service is used for service discovery. So you have, in this example here, we're going to create a service called my app, and we're going to say, I want you to map port 80 to port 3000. And so, and what it's going to do is it's going to use this selector, app, my app. So anything that has a label of app, my app, is going to be targeted to expose port 80. It's going to route port 80 to port 3000 running inside that pod, and it's going to expose it with the name my app. So I can hit this in DNS inside my cluster now as my app. So anywhere that I need to talk to my app, I can just say, HTTP : my app, and it would work. And then finally, an ingress. Ingress is kind of special, and it's kind of funny because it's been beta for a long time and it's finally hit general availability. But I think in Kubernetes 120, or is it 121? It's the current version. In 123, I believe the ingresses are starting to get phased out in favor of another concept, and I forget the name of it at the moment. And the reason is ingresses they're very specific to the implementation. So an ingress exposes your app to the outside world. The default one that comes with Kubernetes is backed by Nginx. The Nginx company also makes their own controller, and you can use like the pro version of Nginx that you pay for with that. If you run on Amazon, you can use application load balancers. The Traffic project has an ingress. Istio has an ingress. Everybody has an ingress now, and HA proxy ingress. And so some of the things that you would do and specify have to be done like kind of in an ingress specific way. So they're redoing the API, so there's going to be less implementation specific items in the definition. But essentially what this ingress is doing is it's going to create an ingress named my app again, and then it's going to say expose this as host myapp.sonicdocs.io. And then when traffic comes in on that, I want you to route it to this service my app on port 80, and you're going to route all anything that comes to root or below that to that application. And so what's going to happen here in this network, and I'll show this, is we have an Nginx controller that's running that the traffic is coming into, and then it's routing it out into our individual application inside Kubernetes. Let's see. Okay, so enough of my talking. Let's look at some code. So let's see, where is my Studio Code? Okay. So what I've got here is, let's see, let me make this a little bit bigger. Full screen this. So I have an application that I wrote in Go, just because quick and easy, and it's very simple. We just spin up a web server. We return, if you hit the /hello endpoint, it will return hello. If you hit the /version endpoint, it will return the version, which is just the GitHub commit hash. And that's it. That's all our application does. If we look at our Dockerfile, switch editors and all your keyboard shortcuts are different. So if we look at our Dockerfile here, we're going to build a container for this application. And in this Dockerfile here, I'm saying I want to use the Debian Buster image as a base. So this is going to set up a change root that has essentially the base utilities that come with Debian Buster as the root. So I'll get bash, I'll get apt so I can install things. I'll get all the basic tools that come with Debian Buster. I could, if I didn't want any of that, I could say from scratch, and then it would it'd be empty. The only thing that would be in this image is what I add to it. And the reason I'm using Debian Buster is I want to show the size difference when you on some of these images use. So what I do here is I use Debian as the base, and then I run the user add command to create a user called greeter. And I set its home directory to the /app folder. I then copy the file main Linux, which gets built by my build, into to /app/main. I change the user that this is going to run as to greeter, and then I set the working directory /app, and then we execute the command. So an important thing to know about containers is by default they're going to run as root, and you typically don't want your applications running as root in production or anywhere really. So we want to drop down to a user with less permissions. So this user is created specifically inside this container and only has permissions to do what we give it, which really is nothing at this case. This file is executable by everyone, so Greeter can run it. Now, let's see. Let's go ahead and I'm going to build him, and then I'm going to run him. So you, that's right. First demo fail of the day. I forgot. I was doing this earlier on Linux, and now I'm on a Mac, and I had cross compilation going. Okay. So if I run main, he starts up, and then he's just waiting for me to hit him with something. So if I open up another terminal and I curl localhost, say hello, oops, port 8090. We can see hello from this GUID. So one of the things that we do is when this starts up, we just create a UUID, a GUID, and we keep that same GUID for the lifetime of the running. And I just did that so we can illustrate showing the lifetime. So this instance happens to be this GUID. If I hit it again, I'll get the same one. But if I stop and restart them, we'll have a different one. So that's the application. So now I've got this app written, and now I want to deploy it. So let's go look at how we do that. So I'm going to create a deployment for this application. Update man. There, so this is just like what we saw before. I'm going to have this application run. It's called Greeter. And I'm going to have one copy of it running, and it's going to run this image. And then I'm going to expose it on this host. This is available on the internet, so if you want to go charge up my Linode bill with a bunch of bandwidth, trying to be a little bit kind to me. And then this is the service that's going to expose it. So let's go ahead and we'll tell Kubernetes. I have a cluster running, and I'll show you that. I've got a few namespaces running here. K is a shortcut. The actual command would be kubectl. I will be typing K because I have it as an alias. So just know that that's an alias for kubectl. I'm lazy. So we can see a few namespaces here. Namespaces are how you provide scoping inside Kubernetes. So we have a Greeter namespace that I created, and I'm going to tell Kubernetes to apply all the files in that deploy/prod folder to the Greeter namespace, not greet. And then if we curl, let's see, what did I say? I said Greeter sonicdocs.io/version. Let's try hello. Do we have a bug? Okay. Let's see. Oh, I did not deploy that image. That's my problem. That's an old version. So right now what I did is I have a little meg file. It's going to build this for Linux. It's going to then build my image, and it's going to push it to my repository. So my repository happened to be running in Docker Hub. If you were somewhere else like Amazon, you would have your big long ECR address in the front here. That's not good. Service unavailable. Unable to push to Docker Hub. There we go. Okay. Whew. So now I'm going to tell Kubernetes to restart that service. Since I actually pushed the right image now. So this is going to restart it. So now my curl should work correctly. There we go. So now it's printing the version number out. Okay, so now we have this running in Kubernetes. We're running on the internet, and we're good to go. It's that simple. So you can see here that my cluster, I just want to show you, my cluster has 3 nodes running inside of it. This cluster is running in Linode, which is a hoster kind of like DigitalOcean. Just quick, cheap, and easy to get a Kubernetes cluster up and running. Took a couple minutes, couple button clicks. Good way for you to play around with it and learn it running in a cloud environment. So now we have this running in Kubernetes. Let's see, what else can we do? We've only got 1 copy of it running. We can say get pods, and we can see that there's 1 copy running. We can say get deployment. And when there's our deployment, we can see 1 of 1. So now let's say we know we want to run more because we want some high availability. So we can say, and go to my notes. And sheet. So now, if we get our deployment, we can see 8 of 10 ready already. It's already got running, and see there's our pod. So this pod's been running for 99 seconds. That's how that original one we started, and then it fired up 9 more to meet demand. And so now if we curl, let's do hello. I got that ID back, and if I do it again, I should get, so I'm going to round robin through all of my different instances here that are running. So now I've scaled out my application. The end user didn't see anything different other than, hey, now their application is running potentially maybe more responsive because I got more instances of this running. So let's show these pods here. So let's say I want to simulate some failure here now. So let me show you. If I say I'm going to delete this pod specifically. So if I do that, and then I get my pods again, we can see that it's already restarted 1. So this guy's 4 seconds old now. So that pod that I deleted, 5J, he's not here anymore, and we have this new one. So we told Kubernetes that we want 10 copies of this running at all times. So if I go in and I start deleting copies, that's not how you scale down. You tell it only run 5 copies or 1 copy. So what I'm going to do is, if I want to go back down to 1 copy, I'm just going to do this, and now it's going to. I'll look at my pods, and we see that all but 1 is terminating. And see, it doesn't keep. It doesn't really matter to it which one it keeps. So we can see it actually terminated our first pod that's 3 minutes and 23 seconds old. It doesn't really matter which one it keeps. There's nothing special about that pod because it was the first one that started. And so now we're back down to just 1 running. I don't know if there's any questions coming through in the chat or not. Okay, so I see a question from Michael Mann. Are the instances bound to a physical machine? What if you want to scale to multiple machines? So if I look at my nodes, I have 3 nodes. Those are the 3 physical machines. They're not really physical, they're virtual machines running in the cloud, but they're my Linux machines that are running Kubernetes for me. So if I wanted to scale out, I would go into my orchestrator in my cloud. So in this case, I would go into Linode and I would say, add 2 more nodes to this group. This is an area that's not something that you can control through Kubernetes itself. You can't say, hey, Kubernetes, I want like 5 nodes. There's an API called the cluster API that is supposed to allow that. It's not, I'm not sure what the status of it is yet. Most people use an orchestration tool on top of that, like Rancher from Rancher Labs. It's free. Actually, Rancher Labs is now part of SUSE. But Rancher Labs provides that. They provide API access. So you can say, I want a node pool, let's say, and I want all the nodes in that pool to have 10 cores and 32 gigs of RAM and 80 gigs of storage, and I want them to all run this version of the operating system. And it will make sure that that happens. And if you want to scale it up, you can do it. And cloud providers like Amazon, it can be part of a like auto scaling group. You can do things like that. So it will, part of EKS can scale out your nodes. Typically, though, you're going to be scaling your pods out before you're scaling your nodes out. But there is support for that. It's just kind of implementation specific. Let's see. Good question, though. Okay, so I've got my simple app running, and let's say now this is all great, but maybe the way I deploy my apps to production is just fine, or I'm not going to change that. But I have the problem where I've got a bunch of different developers all working on the app, and they're all working on different things, and I need to be able to test it and schedule things to go at different times. So I want to, the problem is I need multiple test environments, and it's just, kind of too hard to do with our current setup. So the scenario I'm going to show here is I've actually got multiple namespaces. I've got a QA1 and a QA2, and those also both have copies of the application running in it. And I'm going to set up a GitHub action to when I deploy to a QA branch, it's going to deploy a copy of the application to that namespace, and it has its own URL. And then I can have multiple copies of the different versions of the application running in the same cluster at the same time. And I've broken them out by namespaces, and that can allow my QA team, if I've got this long running feature X and long running feature Y, and I need to test them at the same time, but I don't want them merged yet until everything's done. I can do that pretty easily if I want to have an environment where every time a commit happens, I deploy the application somewhere so I can run integration tests and automated scripting against it. And I don't want that environment to be the same one that everyone's kind of manual testing in, because I don't want them to screw the data up that my automated scripts need. I can do that very easily also. One thing I'm not showing is having any sort of data here, like a database. You can, for these test scenarios, you can very easily spin up a database inside Kubernetes, like a Postgres, MySQL, SQL Server has a Linux version now. I don't know how well SQL Server works with Windows containers, or if it works at all, but you can certainly run the MySQL Linux version, especially for testing. The data engine should be the same. You could do that very easily. And the thing to remember about that is these containers are all ephemeral. So if I were to do anything inside a container onto the disk, and I delete that image while it's running, that data is gone. Now, Kubernetes has a way to keep that persistent. So if you did actually want to run your production database inside Kubernetes, you could. I'm not going to go into that, but you would look at stateful sets and persistent volumes. Those get a little more complicated. There's also projects where you can have custom resources. So just like how we have this deployment, you could have a resource type of, let's say, RDS MySQL. And when you push that out, it will have a controller that's just looking for that, and it's going to go out and create a new instance of an RDS MySQL database and do whatever you tell it to. So you can write your own custom types, essentially, for Kubernetes, and then you implement those in a controller. Typically, those controllers are written in Go, and almost all the code examples you're going to see out there are in Go. but you can write them in Python, you can write them in Java, you can write them in Ansible even. Anything that can talk to the Kubernetes API, you could write a control, and you can run inside a container. You could use to write a controller. So you can, that's a more advanced, much more advanced topic. You can essentially extend the Kubernetes building blocks that way. But let's look at this example here. We've got another question coming in. So to understanding the load, you can say, I don't have the metric server installed, but so there's a project for Kubernetes that's called the metric server, and it collects all the metrics of the nodes and the pods. I don't have it installed in this cluster. So you have to install that in the cluster, and then it gathers all those metrics, and you can see that using the command there. Another thing that you can do inside your spec here is you can set up resource constraints. So you can say that a particular container can only use, like, let's say 2 gigs of memory. Let's say you've got a really hungry Java application that eats up a lot of memory, but you don't want it to eat up more than 2 gigs of memory. So you can specify that in here, and then what will happen is once you hit that limit, Kubernetes will kill it and restart it essentially. There's one for CPU usage also. There's some work around disk quota stuff. I'm just not that familiar with it. Yeah, the cloud provider you use will probably, as Ryan says, have all that integrated. Typically, like if you spin up a cluster inside Amazon or Azure, it's going to install all those things for you automatically to work with their flavor. So like if, for example, if you set up an EKS cluster, they have their own controller that, instead of using Nginx for the ingress, it uses their application load balancer, things like that. I'm just using Linode for this demo because it's cheap, so they don't do any of that stuff by default. So I would have to install the metric server separately, and I forgot to do that. Okay, let's look at a GitHub action really quick. So I've got this quick action here, and if I push to branch 1 or branch 2, I'm going to run this. I've got my kube config file being injected in by a secret. I'm going to check out my code. I'm going to do some housekeeping here to get the branch name. I'm going to use that branch name to set the namespace we're going to use. I set up Go. I build the application. I log into Docker Hub. I push my new image using the GitHub hash as the label, and then we're going to deploy it. So I'm going to use the kubectl command to take this app that I've already got running in there, and I'm going to update the instance. So if I let's see. I'm really good at commit messages. And then we say checkout-b, QA1. Okay, let's say we want to make a change. So in QA, let's change the application. Let's say I want to change hello to say, I want this to be uppercase. So let's see. Change to upper. So I'm going to deploy this to QA1. And then we will have a we go look at our GitHub actions. It's going to run. It's going to do its thing. There's some automated tools that will do this. So if you're familiar with the Jenkins CI tool, there is a new project called Jenkins X. Okay, got to fix that. 1 second. There's a new project called Jenkins X, which is kind of a redoing of Jenkins. It's written in Go. It runs inside Kubernetes. It's native. It will spin up environments and stuff for you. It's very, very complicated. I've used it before. I've worked on it a little bit. It's very complicated, and I actually haven't touched it in years, so maybe it's a lot easier now. But just know that that is out there if you don't want to set up some of this stuff yourself. But this is probably still easier. All right, so what is my error message? Main Linux does not exist, and that is because it didn't update that. So if I go to my CI, I need this to build the file and call it main-linux. And then we go back to our actions. Built successfully, just pushing it now. Okay, now here comes the deployment. Okay, so if I go in my browser to, I believe it was computer.qa1, yep. And there we go. We have our uppercase hello. And then if I go back to my main site, we can see we have lowercase hello. So you could do this with multiple different namespaces, as long as you have access to be able to configure the DNS ahead of time. So some of this is going to require some ahead of time work just to make it easy. You could automate all of this. It's a lot of work to do for a talk, so I did not automate everything. But it is something that I have done before for places in the past inside their own personal clouds. So it's very specific to their setup. So you could run this application. You could have this deploy your code. You could have it spin up an instance of your database and then load it with some test data that you already have. And then you could run your automated test against this or your manual test, whatever you want to do. And then while the whole time you're not affecting anyone else who's in the QA 2 or 3 or 4 environments that you want to do. So it makes it really easy to do that. You're not having to go in and old school applications, you would have to say, okay, I've got this set of VMs that I need for this and for that, and I need to provision them the same way, and I need to make sure it's the same version of Ubuntu and all the same patch level and all that installed. I'm not worrying about any of that right now. I'm just saying, hey, here's this namespace. Go run this code over there in that namespace. And it makes deployment so much easier now. So like my deployment is literally just this particular command here. All right. And so the way this works is Kubernetes is going to say, based off, how you've configured some of the rules, okay, he wants to change the image in this deployment called greeter, in the container called greeter, to this image. So what Kubernetes is going to do is it's going to spin up another pod set to this image and let it get started. and then it's going to, once that guy's up and running, then he's going to kill the other one that's running. So you're not having any downtime. And so if you had 10 replicas, it's going to scale them out. And then you have you can specify how many instances you want based off a percentage. Like, you know, at least 50% of all the pods have to be running. So if I had 10 running, it won't kill more than 5. It'll always keep 5 running at a time. So you can do that quickly. Let's say we realized, oh no, this code is bad, it's a bug, and we got to roll back. Well, we just run this command again, and we give it the previous version, and it rolls back. Now, of course, you have to design your application to work that way. So, you know, this makes, you know, one part of this really easy. The other half of this is you have to make sure your application is designed for that. So, if you have database changes that are going to take a while to run, you know, you need to make sure that they run before you do this. And you need to make sure that both versions of the application can work with those changes, the current version that's in production and the new version. If you're renaming a table or changing a column or something, you know, you have to do that in steps. And you have to make sure that if you find a problem, you can roll back the deployment of the application. You're not going to be rolling back necessarily those database changes. So you're not going to rename a column in one step. You're probably going to do that in 2 steps. You're going to add a column, update code to start reading from, still read from the old column, migrate data, read from the new, etc. So it can be a multi-step process, but deploying the application bits doesn't have to be hard. The rest of it still can be a challenge, but the deployment, can be easy. Okay, I think that's about it for my demo, unless anyone wants to see anything else there. Let's see, we'll go back to our slides though. Okay, so Kubernetes is this big, complex piece of software. It was the new hotness a few years ago when I started using it. It's not necessarily the new hotness anymore, but it's still, still a lot of people are not using it yet. So why would you use it? If you have a really complex deployment process where you have lots of different moving pieces, lots of different applications that need to get deployed, it can simplify that greatly. It's really just updating a YAML file. You know, I showed one command where I said set image. I could have easily, if we go back here, I could have easily changed the value in here and then just ran that apply command again. And it's gonna do the diff on its end and just update what's been updated. If you've got lots of different components and services, so I've worked on systems that had 20, 30, 40 different services that need to be deployed, and they need to be deployed some at the same time, unfortunately, and some don't have to be, but this makes it easy to help manage that. If you want to simplify your infrastructure management, so you're not managing a bunch of different VMs for different purposes. You're really just managing a cluster of VMs that are going to run all of your stuff. Kubernetes makes that easy, and you can have different classes of VMs in there too. There's a concept, it's called taints and tolerations in Kubernetes, where let's say you had some machines that you want to do some machine learning on, and you got some really beefy GPU instances in Azure, and you're going to train a model on it. You could use Kubernetes to deploy it, but you don't want your web app to deploy on these machines with these $1,000 an hour GPU machines. You just want your models to deploy on it. So you can add taints and tolerations to those particular deployments and those nodes, so that when you deploy your web app, he doesn't get scheduled onto the GPU machine, but when you deploy your model training app, he does get scheduled onto the GPU machine. And that way, one, not every cluster in your Not every node in your cluster has to have a GPU and be capable of that, so you can cut costs down from there. So you can have, multiple different tiers of clusters of nodes, and schedule appropriately if you wanted to. Kubernetes helps you support multi-cloud deployments. Now, for most people, you're like, oh, we're only on one cloud. Like, we're on Azure, we're not switching, right? We're on AWS, we're not switching. So it's kind of like databases. People don't change databases. And that's true. But where this does help is, any company of any, significant size is eventually going to merge with another company, either buy or be bought by. And you may get merged with a company that's running in Amazon and you're running in Google Cloud, or you're running in Azure. And so now if you're using Elastic Beanstalk and Amazon to deploy everything, and now your new company is running Azure, you can't really take that for one-to-one. But if you have this multi-cloud system set up, you're kind of already ready to go. And so, when you're bringing on some other groups and, you've acquired some new technology, you just say, hey, Dockerize this. We're going to run it in Kubernetes. And your path to getting on our infrastructure is easy. We kind of showed this already. Multiple testing environments makes it super easy. You can have multiple manual testers who can go in there and they can do whatever they want to the data and screw it up. And then you can have a separate environment that's got the same initial seed data, and your automated tests run, and it generates tons of fake users that you don't want to see in the rest of your test system. So you can isolate it over there. But the most important thing is you need to make sure you have resources to support it. When Kubernetes first came out, it was really hard to get up and running. Really hard. And until there were some projects, like one was called COPS, which stands for Kubernetes Operations. That made it easier to install Kubernetes into AWS. And then eventually you had Azure offering Azure Kubernetes service. Then Google started offering its service, and now every cloud has a Kubernetes service. So getting Kubernetes initially set up is much easier than it used to be. But there are still things that you need to know about Kubernetes, and you need to be able to have someone on your team dedicated to being able to support that. So when should you not use Kubernetes? If your app is just a basic CRUD application that can run on a little T2 medium instance, and you've got just a couple hundred users, and you can take the app down for 10 minutes to do a deployment, you don't need Kubernetes. And this is a large chunk of internal line of business applications. You don't need Kubernetes. You don't need all the power it provides. If you're just getting started out on your application, you don't necessarily need to say we're gonna Dockerize this thing and we're gonna run it. You need to prove out your idea first, and then once your idea has some traction, then you can figure out how you're going to use Kubernetes to scale it. And once again, if you don't have the resources to support it, back to that line of business comment though I made. If you're a small company and you just got a few applications, sure, you don't need it. If you have, dozens or even hundreds of internal applications that need to get deployed and supported and managed, then you might want to start looking at Kubernetes to manage your internal set of applications. If you have public-facing applications, same deal. If you're small scale, you don't need Kubernetes. But once you get to a point where your deployment is now complex, scaling is difficult, that's when you want to start looking at a tool like Kubernetes to bring in to help you. What I would recommend, though, is regardless of using Kubernetes or not, I would recommend that you look at containerizing your applications. Kubernetes is not the only orchestrator. It is the biggest one. The most has the most traction behind it, but there's also Amazon's EC Elastic Container compute container, forget the name of it, ECS, Elastic Container Service. That is kind of a competitor to Kubernetes. It also runs with it. I think Azure has the ability to run containers too. So the containers are very helpful because they make things portable. So I can say this application, I can package an application with all its dependencies and then not have to worry about, is it going to run on your machine or my machine? If you need a very specific version of, Python or some library, and you don't want the person who's going to be running it to have to do a lot of work to get that very specific version to run, then package it as a container, and then they'll be able to run it no matter what. All right. I think that's it for me. I think I've talked for over an hour now. So are there any other questions? Anything that anybody would like me to review again?
Yeah, I'm not seeing any new questions
All right.
in the chat. Yes, go ahead and post them in the chat, and we'll get to them.
Okay, yeah. So Ryan says that he loves having a Docker image for SQL Server, and he's interested in having an image for his development environment. Yeah, using Docker for your development makes things so much faster, easier to do. So instead of having to install SQL Server and then get the the database seeded and then install all the different applications, I can just run them with Docker. You can do something like Docker Compose to help you there, so you can run that locally. So David Fecky just asked, is Kubernetes removing the need for using Docker containers? So no. So recently there was an announcement that Kubernetes was dropping support for Docker, and what that means is they were dropping support for using Docker as the runtime. So there are multiple different runtime engines for containers. They're all based off that OCI spec that Docker donated back in 2015. So Docker is one of those runtimes. There's also Creo. There's Containerd. There's Pod. There's all kinds. And Docker's a little heavy-handed. It requires a service to be running in the background that manages everything, and then you talk to it through RPC using the Docker command. It's talking to a service in the background. And Kubernetes is dropping support for using that. So they're going to use Containerd directly to run, and that's the service for running containers that Docker also uses under the hood. They're going to use that directly. And so you don't need Docker installed on your Kubernetes nodes anymore. When Kubernetes first came out, it used Docker. And so they had a little shim that would talk to Docker over this network. They're not doing that. They're dropping support for that. So they're going to use Containerd, I believe. But the image you build, whether you build it with Docker or anything else, it's an OCI image. It's going to run anywhere where OCI images can run. So continue to use Docker for local development because it's the easiest way to do it. And then even building your images if you want, but the runtime doesn't matter there. Good question. There is also a project called KubeVirt. And the kind of what you see as the long-term thinking is Kubernetes will evolve beyond just a place to run your containers. It will be a place to essentially run your entire cloud. So KubeVirt is a project that allows you to specify, just like we saw with like a deployment or a service or something, you specify a virtual machine, and Kubernetes will talk to your cloud provider, its virtual machine manager or whatever, and it will spin up a virtual machine for you. And so it's using Kubernetes to manage all your resources in a declarative fashion. So there's a project I mentioned earlier too, where you can actually use Kubernetes to create an RDS instance for you in Amazon. So you could say, hey, I want a MySQL database. And then you give it this YAML file, and then it makes sure that that MySQL database gets created inside your Amazon account inside RDS. So Kubernetes is not actually running MySQL at all. It's just doing all of the work to talk to AWS for you and create that instance. All you did was give it a YAML file and say, I want an RDS instance that looks like this. And Kubernetes will make sure that as long as that YAML file is there like that, that you'll have an RDS instance running that matches that definition. So it's really turning all of your infrastructure into this desired state configuration. So you just say, I want my infrastructure to look like X, and Kubernetes will, with all the plugins and stuff that are being created for it, will make sure that your infrastructure looks like X. And when it deviates from that, it will do everything it can to get it back to that.
Cool. I was going to throw out a question to everybody who's attending. How many of you are using Kubernetes currently? I just wanted to see a show of hands. How many people are actually using it right now? All right, there we got one. And it was with Kubernetes coming on in 2019, with SQL Server 2019, having the ability to build out big data clusters. I know that that's become a new thing in the SQL community. So I know a lot of people are starting to use that.
Yeah, for a while there, I would have said if you want to run anything with state, like a database in Kubernetes, for anything other than testing and development, I wouldn't recommend it, because the story for stateful applications wasn't that strong. But it's come a long way now, and they've done a lot of work there. And I think it'd be a safe option to run it there. Before it was just a lot of work, and it was kind of difficult to get things to work the way you needed them to. But like I said, a lot of work's been done there, and I would probably I'm of the mindset that I'm not a DBA, and I don't want to play one on TV either. So I like to let other people run my databases for me. So I would use something like RDS. But if you are comfortable with running, you already run a database on a Windows machine anyway for SQL Server, then yeah, go for it. Run it in Kubernetes. And then, it'll give you a little bit more power and flexibility that you wouldn't have just, running it on a server. But for me, if you're not a DBA, let the DBAs run the database for you.
Yeah, I'd second that.
Yep. You can with Docker, you can have your data stored outside. The issue with Kubernetes is since you're in a cluster, if your container stops running, you're not guaranteed that it's going to start up on the same node that it was before. So it wouldn't have access to that data that you might have stored outside on that node. So they have added the concept of persistent volumes and persistent volume claims. So you may have a persistent volume that's blocked by like EVS storage, and then it'll handle mounting that to the appropriate node and into the appropriate container when that starts up.
Yeah, it's just similar to cluster configuration for sharing data.
Exactly. So it's just a little tricky, and you just got to make sure you got everything right. I mean, it works great now. Back in when people were first trying to do this, it was not all the pieces were there that were needed to build that. They're all there now, and they all work. It's much easier to do inside a cloud, like AWS or Azure. If you're running Kubernetes inside something like OpenStack, which is kind of like an open source cloud provider for your own data center, that you might do at Rackspace or something, It's a little bit more difficult because you've got to make sure you've got all the storage plugins and all that kind of stuff set up correctly. But yeah, if you're running it inside of one of the big clouds, then you're good to go. So Michael Mann asked, what is the best practice for partitioning environments in dev, QA, or prod with Kubernetes? I would use namespaces. And honestly, I would probably have a separate cluster for production, and then a cluster for everything else, like test, QA, just for that extra isolation, especially depending on what kind of production you're working with. If it's any sort of PCI or HIPAA data or anything like that, you probably your auditors are probably going to require you to have that separate anyway. So I would have a separate cluster for production. You can use namespaces to isolate things. There are network policies in Kubernetes. You have to install a CNI, a container network plugin, like Flannel or Istio has one. There's all these. But you can do network policies. Amazon has one, I think it's in beta still, where the network policies are backed by Amazon security groups. But essentially, you declaratively say, I kind of like you define a security group in AWS. The traffic can go from, these IP ranges can talk to these IP ranges over these ports, and that's it. And you can define that declaratively in Kubernetes. You could lock your cluster down so that it can't talk to anything, and then slowly open it up to only allow it to what to talk to. That's definitely a recommended best practice for production. I would do the same thing in dev, test, QA, just so you can catch any configuration issues. But for running the clusters, I would have a decent cluster for production, and then you could have a smaller cluster for to run your dev, test, QA in. As long as your auditors will be okay with that, any sort of data mixing there.
Yeah, I would think if you stood up your own unique cluster per environment, that would be best.
So you do have,
you can deploy your updates to it, right?
Yeah. So if you do an environment, a cluster per environment, you do have more overhead because you have for every cluster you have a control plane. So that's also a set of machines. Now, the cloud providers abstract that away from you, but they've all started charging for that. So, excuse me, it's around a $75 a month charge just to have a cluster, and that's to cover the control plane resources. So that's another set of machines that you don't see that's running the Kubernetes API servers, and it's also running etcd, which is what Kubernetes uses to have its distributed state for its API deployed there. So for every cluster you spin up, you will have another control plane. And, I think Azure charges like $80. Amazon, I think, just started charging. Google's charging around $70 or $80 for it. They provide an SLA on it, but it is just something to be aware. I mean, it's not a totally big cost, but it is something to be aware of. And then your upgrade cycle will be different. So the way you upgrade Kubernetes is you want to upgrade the master, and then the cloud providers do that. They usually just a button like, hey, there's a new version available, and you hit upgrade, and then it goes off for 15 minutes, and you don't notice anything, and then it's running the next version. Your nodes, though, don't get updated, so you need to tell those nodes to be updated. And typically, what you would do is you would cordon off a node which says, hey, don't schedule any work on this node. And drain it. So get all the work that is on that node and move it to a different node. So there's nothing running on it. And then you can kill that node and then spin up a new node on the new version of Kubernetes. It'll rejoin the cluster. And then you can, start rescheduling work on that new node. You would, cycle through all your nodes, depending on how much nodes being down you can tolerate, one at a time, two at a time, whatever it is. And then till you get to the next version. You can't skip versions. You can't go from 119 to 121. You have to go 119 to 120 to 121. So It's best if you stay up to date. Kubernetes comes out, I think they have 3 releases a year now is what they're targeting. So they move kind of fast. So, you want to stay up to date. Another thing that'll happen is the cloud providers they'll only support a few versions back. So if it's on 120, they only support 18, 19, and 20. So if you're on 117, they're gonna force the control plane to be updated probably, and then you'll have to upgrade your node. So you want to stay on top of that if possible. So that's another downside of having multiple clusters, is it's just more administrative overhead that you gotta be aware of to take care of.
Cool. Any other questions? Do you have a contact slide there, Jason? If anybody has any questions, to reach out.
Yeah, we can go. Let me go back to the top. So yeah, I'm at the Jason Gerard on Twitter. That's probably the best way to get a hold of me. I'm also LinkedIn / Jason Gerard. You can find me on LinkedIn. But my DMs are open. So if you just want to hit me up to talk about anything, hit me up on LinkedIn, hit me up on Twitter. And I'll get back to you. If you got any other questions, you got a problem you're stuck on, feel free to reach out and hit me up, and I'll see what I can do.
All right. Awesome. Thanks.
Yeah.
Thanks
for your time.
Tonight.
Yeah. Thanks for having me.